Okay friends, so now today is our day 3 of GCP certification that we have started. Today's topic is GCP storage and database. So today we are going to discuss how we can store data inside Google Cloud. So actually first we should understand what kind of data we have. Only then we can decide the solution in which or service which we are going to store our data. So there are mainly five types of data storage service. There are others also, but these are the main five services that I have discussed in this today's session. So first one is cloud storage. As you all might be aware of this kind of storage, cloud storage. Cloud storage is a kind of storage that is present in almost all the cloud providers, just the names are different. So cloud storage, or it's also known as object storage. Like in AWS we have S3, similarly in GCP we name it as cloud storage. Then we have Cloud SQL. Cloud SQL is the RDMS database or managed database service which are provided by the cloud provider or GCP. In GCP we call it as Cloud SQL. There are mainly three flavors of Cloud SQL which are available in GCP, which is PostgreSQL, MySQL and SQL Server. Then we have Spanner. Spanner is the GCP own database. It's a kind of RDMS database. So GCP claims that all its RDMS or relational databases are stored in Cloud Spanner. It can be expanded horizontally. It's a very good and very big database type that we have in GCP. It's GCP own database. GCP created Cloud Spanner. Then we have Firestore. Firestore is a non-relational database or NoSQL database that we have in GCP. We can store semi-structured or unstructured data inside it. Then we have Bigtable. Bigtable is mainly if we have large amount of data that we want to store in cloud, and if it's an unstructured or semi-structured data, that can be stored in Bigtable. So let's go and deep dive in each and every cloud storage that we have. Let's first start with cloud storage. So what is cloud storage? As I told you, cloud storage is an object storage. It's a computer data storage architecture that manages data as object and not as file and folders. Hierarchical file storage or as a chunk of disk block storage. So in case of object storage, the data is not stored inside. Generally when we have any data, it's kind of file folder structure that we have in our computer, in our system, right? And that data is stored as, the data is considered as a disk block, which we can edit it, we can change it, we can delete it. But in case of object storage, the data is considered as a complete object, not a data block. It's considered as a complete object which is stored inside a storage space, and this object storage has its own metadata. So by metadata I means it has its own definitions, it has its own date, creation value, size. These all are metadata of a particular storage, so particular data. So in object storage we store the data, and that data is known as objects. Mainly what kind of data we are storing here? You can think of a picture, you can think of a file, you can think of a video. Any data that you can think of that can be stored inside a cloud storage. You can upload that data inside the cloud storage bucket that we have. In cloud storage we create a bucket inside cloud storage, and in that bucket we store the data. That bucket is globally unique. You cannot have a same name bucket inside a project. It should be globally unique, and it also provides a URL, so you can browse that data using that URL. So you have uploaded a picture, you have created a bucket inside a cloud storage, and inside that bucket you have uploaded a picture. That picture will get a cloud URL. You can use that URL. If that is considered as public, then you can use that URL to browse that picture. I will show you in the comment section. At the time of lab I will show you, if we store any data inside the cloud storage, we can use the URL to see or view that data or download that data. So that is about cloud storage. Then cloud storage data commonly stored as object includes video, pictures, audio and recordings that I told you. Binary form of actual data itself. So it's a binary form of actual data, relevant associated metadatas, and globally unique identifier. I told you about all these three things. Now this unique key are in form of URLs. So this bucket, inside that bucket, when you store the data, you get a URL, and that URL, using that URL you can access the data commonly stored as object includes video, pictures and audio recording, can store any amount of data and can retrieve it easily. So there is no limit as such for storing data inside cloud storage. You can store any amount of data inside the cloud storage, and it can be retrieved also very easily. The retrieval process is very easy in cloud storage. So you can just use that URL, or you can download the data directly from the cloud storage. Fully managed scalable service that has wide variety of use cases. So cloud storage is fully managed. You don't have to manage anything. It's managed by the cloud provider itself. It's a scalable service, so there is no limit for the size, and a wide variety of data can be used. Like a website content can be stored inside the cloud storage. Archival or disaster recovery data can be stored inside the cloud storage. Direct downloads, you can download directly. Direct downloads can also be stored inside the cloud storage. Primary use as a blob. So blob data, blob data can mainly be stored inside the cloud storage. Then we have cloud storage features. So cloud storage files are organized into buckets that I have told you. Inside the cloud storage you have a bucket, and inside that bucket you can store the data. These buckets are globally unique identifier. Cloud storage is immutable. What do you mean by cloud storage is immutable? So once you store any data inside the cloud storage, you cannot edit it. When you edit it, a new version of that data gets created. So if you enable versioning on that data, similar to the Excel file, if you have versioning enable on your Excel file, when some edit is done, there is a history created at the backend. You can see at which version the particular file got changed. So you can track the changes, and also you can roll back to the specific version if you want. Same feature is available in cloud storage as well. You have a versioning feature in cloud storage. If you enable that versioning feature, the you once you store some data and you edit it, a new version of that data is created. So version 1, after that version 0, version 1, version 2, like that, version 3, version 4, like that. New versions will keep on getting created once you do any update on that particular data. And suppose if you have disabled that versioning, then that complete data will get a new version of that data will get created, and the old you don't have any history, so you cannot roll it back. By rollback I mean, suppose you have version 0, version 2, version 1, version 2, version 3, version 4. On version 4 you made some changes, but the changes are not looking good. You have made some mistake. You want to roll it back to the version 3. You can select and roll back to the version 3. You will get the old data. You can enable versioning so that the historical data will be saved. If you disable it, will update the current version. Using and how this cloud storage can be accessible. Cloud storage can be accessible by using IAM rules. You can restrict the access on the cloud storage using IAM permissions. So you can grant, delete, update permissions can be granted using IAM. Or also in cloud storage we have access control list. Using this as access control list, you can define the scope. Scope is the user which is going, which and what permission that scope has. So that would be using ACL's access control list. You can refine the finer control the permissions or refine the permissions. So these are the two ways you can restrict the permissions on the cloud storage, using IAM or using ACL, access control list. Then we have life management policy to manage the data inside the bucket. What I mean by life cycle management policy, in life cycle management policy you can mention, suppose if you want to move the data or delete the data after some particular time, you can have a management policy in which you can mention delete all the versions which are older than a week or older than a month. If you have that policy enabled inside the cloud storage, it will automatically delete all the older versions. So you will not pay more unnecessary cost. You will not have to pay unnecessary cost for any storage that you are using. So life cycle management policy is also available in cloud storage buckets. Then storage class. So there are multiple storage class that we have. We are going to see that in the next slide. But what that storage class provides ultimate storage. So what are the different features that we have for the cloud storage? Whichever storage class it is, it will provide you a low latency. So this cloud storage is mainly created in the region where you have your servers or where you are going to use it. So the latency is very less. Suppose if you have a application or a web server and the web server content content is stored on the cloud storage. So it's recommended to have that web server and the cloud storage in the same region itself. So the latency is low. High durability, so the data inside that cloud storage is highly durable. It cannot be deleted, or it cannot be, you cannot lose that data. You have a continuous backup of that cloud storage. So the data will ultimately will be present inside your cloud storage. Uniform experience and geo redundancy load balancer traffic for optimal performance. You can have the, this cloud storage, you can have this data is getting synced at the backend. The Google takes the backup and stores data at their backend network. So if you want to have a data accessed from any other region, you can access it using load balancer, or opt for load balancing the traffic. It's not a load balancer, it's traffic load balancing using the Google internal network to access the data, access the cloud storage data, and have good performance. In order to get the good performance, it's worldwide access. So that's about cloud storage features. Then I was telling you about the different types of, or different classes of cloud storage. So mainly there are 4 classes of cloud storage: standard storage, nearline storage, cold line storage, and archival storage. These all depends, actually the price goes from here to here. So standard storage is higher in cost than the nearline storage, then the cold line storage, and archival storage is less in cost. Similarly, you can store the data. So if it's less in cost, so you can archival storage, mainly you store a data which you are going to retrieve once in a year. So very old data which you only require once in a year, you can store it in an archival storage. So that data will be stored in very it will cost you very less. Then comes the cold line storage. So if you are accessing any data once in every quarter, basically you can store that data in the cold line storage, so it will cost less. Nearline storage, so nearline storage is similarly, if you are accessing any data on a monthly basis, you can probably store that data in a nearline storage, so it will cost you less. Standard storage is a hot data. If you want to access, update and delete a data on a daily basis, you can probably store it in a standard storage, and that will be accessible once you when you want. It will be highly accessible. The latency between the standard storage and the user will be very less. Latency between the nearline storage, cold line storage, and archival storage will be probably high. Then comes the auto class. So what is auto class? You can have, similar to the life management policy, in which you can define if a particular data can be deleted after a specific time. In auto class also you can define if a data is of 100, if of suppose if you have a data inside the storage, standard storage, and you want to move it to the cold line storage after every 3 months or after every 2 months, you can define a policy inside the auto class. It will move that particular data. Once it's 2 months old, it will move it to nearline storage. Once it's 180 days or 240 days old, it will move it to cold line storage, and then once it's 1 year old, it will move it to archival storage. That's how you can define a auto class, which will move the data from one class to another class to save the cost. Pay as you use, no prior provisioning or capacity is required. Encrypted data on the server side use HTTP and TLS security. So cloud storage, as you know, all the cloud services are pay as you go model. So how much storage you will use, that much you have to pay to GCP. No prior provisioning is required. So if you want to store any data for, suppose if you want to store 1 GB of data, you don't have to store it. You don't have to, suppose if you want to store any data for 1 year, if you want to store any 1 GB of data or 1 TB of data, you don't have to get the storage provision before you want to store. You don't have to get prior provisioning of the capacity is not required. Once you want it, you can create the storage and start storing the data. These data, all the data are encrypted. You don't have to encrypt any data, and the movement of the data from transferring of data is also HTTP and TLS secured. So HTTP and TLS protocols are used in order to access these data. So this data is completely encrypted and safe. How you can access and upload the data. So you can upload the data using GCP console itself. From the GCP console, you can drag and drop the data. That is one method. Another method is using CDK, G Cloud commands. You can open a cloud shell and cloud console. In the cloud console, you can open a Cloud Shell and use gcloud command to create the bucket, upload the data inside the bucket, delete the data from the bucket. So you can use CDK, Cloud's SDK, to store the data. Store the data. Storage transfer service, another service is storage transfer service to cloud storage from another cloud. If you want to store data from any other cloud, like from S3 to cloud storage, if you want to move a data, you have another service in GCP which is known as storage transfer service. You can use this service to move the data from one cloud storage to another cloud storage, to GCP cloud basically. Then we have a transfer appliance. What is a transfer appliance? Transfer appliance is a kind of snowball service that we have in AWS. It is a physical storage device in which you can save your data. Then that physical device will be shipped to the GCP data center, and from there it will be uploaded to your cloud bucket. So you have a transfer appliance. So there are basically 4 methods through which you can access or upload or transfer data inside a Google Cloud Storage. The first one is using the Google Cloud Console. Second one is using Google SDK. Third one is using storage transfer service, and the fourth one is using by transfer appliance. So if you see right here, we have the using console, we have it SDK, then we have storage transfer service, and then we have transfer appliance to transfer the petabyte of data using physical storage device. And it's integrated with other cloud services like BigQuery, Cloud SQL. So cloud storage, since it's a GCP service itself, it's integrated very easily. It can be integrated with other services like BigQuery, Cloud SQL, Cloud Storage, App Engine, Logs, File Storage, Backup, App Engine, objects like images. It can also store instance, startup scripts, compute engine, images, object used for compute engine. So these are different types of data that can be stored inside the cloud storage using different cloud services, using different GCP services. So these all GCP services you can use to store or leverage the cloud storage service to store their data inside the cloud storage. It's a very important service used in the architecture. When you create any architecture, cloud storage is mainly used. So it is easily integrated with other cloud services that we have. This is about basically about storage class, or this is about cloud storage. Now let's move to Cloud SQL. So Cloud SQL is basically a relational database service that we have in GCP. It's a managed database service. Like in AWS, we have RDS, relational database service. Similarly, that relational database service is known as Cloud SQL in GCP. So in GCP, Cloud SQL mainly comes in 3 flavors, or in 3 RDBMS are mainly supported, which are MySQL, PostgreSQL, and SQL Server. See, these 3 RDMS are as of now supported in Cloud SQL. So you can, if you want to create any MySQL, PostgreSQL, or SQL Server database instance inside GCP, you can use this Cloud SQL service and create a particular instance of these MySQL, PostgreSQL, or SQL Server database. So for example, if you want to have a SQL Server, what you generally do, if you want to create a database, SQL Server database, what you have to do is you have to create a VM and install a SQL Server inside that VM, and then create a database inside it, right? Or if you want to have a MySQL, if you want to use a MySQL for your application, you have to create a VM, install MySQL on it, and then create a database and start using by your application. Now what cloud provider does is cloud provider provides you the instance like MySQL instance, PostgreSQL instance, and SQL Server instance. These 3 instances are available in cloud. You can just go ahead and create those instances. There are different configurations that you can select for these instances at the time of creation. Once these instances are created, then it will be managed by cloud provider itself. You don't have to patch it, you don't have to update it, you don't have to take the backups. These all functionalities will be taken care by the cloud provider. You just have to create your database and start using with your application. It's a kind of platform as a service, PaaS service. Cloud SQL is a PaaS service. So application. So these are the 3 flavors that we have: MySQL, PostgreSQL, and SQL Server. Then applying patches and update. So this is managed by Cloud SQL. Patches and updates will be managed by Cloud SQL. Managing backups will be taken care by GCP itself. Configuring replication, this will also be taken care by GCP themselves. So you don't have to take care of all these infra level features. You only have to take care of your database. You have to just create the database, create the tables, and start using with your application. Doesn't require any software installation or maintenance. Cloud SQL does not require any software installation. You just have to create the database, can scale up to 128 processor cores, 864 GB RAM, and 64 TB of storage. So 64 TB of storage, as of now, 64 TB of database can be created inside a Cloud SQL service. So these can scale up to 128 processor and 864 GB. So when you start creating a Cloud SQL instance, you will get a different instance type that you can select for creating your Cloud SQL instance. So that this configuration will depend on the instance type that you are going to select for creating your Cloud SQL instance. Suppose if you are creating an N2 standard 2 instance, so that will have less CPU and memory. Similarly, this is the maximum configuration that you can have in the Cloud SQL: 128 processor, 864 GB of RAM, and 64 TB of storage. Supports automatic replication scenario. So supports automatic replication scenario. What it means is we can create a replication server from the Cloud SQL, MySQL, PostgreSQL, and SQL Server. We can create a replica. We can also have a DR instance created for the Cloud SQL instance. There is a limit for number of replica that can be created for each even for the primary as well as for the DR instance. So automatic replication scenario is supported by Cloud SQL. You don't have to configure any replication, or you don't have to, for SQL Server, you don't have to configure any mirroring or lock shipping in order to configure the replication. It's automatically, you have to just select that option, and replication instance, a read replica will be created for your Cloud SQL instance. Support managed backup. The cost of an instance covers 7 backup. So support managed. So Cloud SQL backups are automatically taken. You can have the time frame at which the backup needs to be taken, that can be managed, that can be set by you, and once the time frame is set or the period is set, then the backups will be taken automatically by the GCP. You don't have to manage, no human intervention is required for taking the backup in the Cloud SQL. Encrypt customer data when the Google internal network, when on a Google Internet Network, and when stores in database table, temporary files, and backup. So these data encrypt the customer. These data are already, so Cloud SQL supports data encryption at rest and encryption at transit. You can enable TLS and SSL protocol to enable encryption in transit, and at the rest, when the data is stored inside your database, that data is already encrypted. Include network firewall. So there will be a firewall attached to your Cloud SQL instance. You can manage the firewall rules by allowing or by denying the rule to enable the connectivity from another instance to your Cloud SQL instance. Can be accessed by other GCP service. So Cloud SQL is easily connectable with the other Cloud SQL services like Compute Engine or with other BigQuery. So you can integrate both Cloud SQL with other services. It's easily manageable, and the table and the database can be used by Compute Engine. Suppose you have an application installed on your Compute Engine, you can connect your application with the Cloud SQL instance. So that is about Cloud SQL. Now we have Spanner. So Spanner is a fully managed database service that scales horizontally. It's strongly consistent and it speaks SQL. So Spanner is a relational database service provided by GCP by Google itself. Google claims that all its relational databases are stored in Spanner. All $80,000 business has been done from the Spanner itself. So it's highly reliable service now, and it's a highly scalable service. If you like in Cloud SQL, you have only 3 flavors that are supported, like MySQL, PostgreSQL, and SQL Server. If you want to create your own RDMS database, you don't have dependency on a specific SQL Server flavor, you can use Cloud Spanner. It is also a relational database service. You can store your data in a table format and then use that data. It's a horizontally scalable. Scalability is more in Spanner than in Cloud SQL, and also the data storage part. The storage of Cloud Spanner is more than what you have in Cloud SQL. Spanner is used by Google themselves. Support SQL relational database system with joins and secondary indexes. Built-in high availability, strong global consistency, and high number of input and output operations per second. So Cloud Spanner is very fast in nature. It's more fast than the service, that Cloud SQL service that we have. So this is a high level about Cloud Spanner. Then we come to Firestore. Firestore is a flexible, horizontally scalable NoSQL Cloud SQL database. So now NoSQL Cloud database. So what's Firestore? For now NoSQL databases like unstructured or semi-structured data, you can use Firestore. Firestore stores data in a key value format, and you can store it inside the Cloud SQL, and it's a horizontally scalable NoSQL database. Data is stored in a document and then organized into a collection. Each document contains a set of key role pairs. SQL query can be used with filters and sorting options. So you can use normal SQL queries to fetch the data from the Firestore. Firestore is very fast in nature, so you can get this key value pairs can be fetched very quickly using the SQL query. You can also use filtering and sorting options inside your SQL query to fetch this data. They are indexed by default. So in the Firestore, the data which you store in a key value format, it's already indexed, so you don't have to index the data. So that SQL query is not running at a data level, it's running on your index level, at your query level. These are indexed by default, so query runs faster. It caches the data and that the app is using frequently, so reading and writing can be faster. Another important service of Firestore is, if you don't have a dependency of an online database, you can store your unstructured data inside a Firestore. It has a caching feature, so the frequent data that you are accessing from the database can be stored inside the cache, and you can read the data or edit the data from the cache itself. Once your database is online, then this cache gets synced with your original Firestore database. That is about Firestore. Then we have Bigtable. Bigtable is a Google NoSQL database service. Bigtable is a Google NoSQL database service. So as like Firestore, Bigtable is also a Google NoSQL database. Just the storage part in Bigtable is more. You can store more data. Like if you have 1 TB of semi-structured data, it's best choice to store it in the Bigtable. Because Bigtable, it's the same database that powers many core Google services, including search, analytics, maps, and Gmails. So it's all these services, all these storage services that we are explaining in this video. It's mainly used by Google themselves to provide their services that we have, like map services, Gmail services. They use these databases itself, which they are providing to their customers. So Bigtable is a Google NoSQL big database. It's the same database that powers many of the Google services. Bigtable is designed to handle massive workloads at consistent low latency and high throughput. So it's very fast. Actually, the latency in Bigtable is very less, as well as the throughput is very high. It's good choice for analytics, financial, and internet of a thing. It's good choice if you have more than 1 TB of semi-structured data. So if you have a large amount of financial data, analytical data which is semi-structured, the best choice for you is to use Bigtable. Data is fast with high throughput, or it's rapidly changing with NoSQL data. So if you have a NoSQL data which is rapidly changing, Bigtable is a very good option for you. You can store that big data inside the Bigtable and can be retrieved very fast. Streaming data and batch processing data. So Bigtables are mainly used for if you have a streaming data, like if you are streaming any video, or if you have any batch processes that are running, that can be stored inside the Bigtable. Since it's very fast, so the process will be very high, where process can be done very easily. Comparison of different cloud storage. So which cloud storage should be used at which point of time? Cloud storage, consider if you need a store immutable blob larger than 10 megabytes, such as large images or movies. This storage service provides a maximum unit size of 5 terabyte per object. So cloud storage is a best service if you have an immutable block larger than 10 megabytes. That data can be stored inside the cloud storage. So actually in this slide, what we are trying to explain is which cloud storage service you should use based on data. So what kind of data you have and what's the purpose of the data. Based on that type of data and the purpose of data, you can select which service you should use. So cloud storage service you should use if your data size is very high, you have 5 terabytes of data, and that data is a blob, is a unstructured data. Then the best service that you can use in Google Cloud is cloud storage. Cloud SQL, consider using Cloud SQL or Spanner if you need a SQL support for online transaction processing system. So if you have an online transaction processing system, OLTP system, and you want an RDBMS data, your data is a relational structured data, then probably you can go with Cloud SQL. And in which scenario you should go with Cloud SQL, and in which scenario you should go with Spanner? Suppose your data size is very large and you want to have the functionality of horizontal scaling, then the best option is with Spanner. If your data is less in size, up to 64 terabyte, then go with Cloud SQL. And it also depends on the application dependency with the database. Suppose if your application is only compatible with MySQL, then you cannot go with Spanner. You have only option to go with Cloud SQL MySQL version. So consider Firestore if you need massive scaling and predictable performance together with a real-time query results and offline query support. It supports terabyte, maximum unit size is 1 megabyte per entity. Firestore is best for storing, syncing and querying data from mobile and web applications. So this statement itself is explanatory. Consider Bigtable if you need to store large number of structured objects. Bigtable does not support SQL queries nor multi-row transaction. It provides petabytes with maximum unit size of 10 megabytes per cell and 10 megabytes per row. So Firestore you can consider if you have a semi-structured or unstructured data, you can store it in the Firestore. If you have a key value pair kind of data, you can store it in the Firestore. Bigtable, when you have large data, a large number of structured data, then probably go with Bigtable. But only problem with Bigtable is it does not support SQL queries. So if you don't have any limitation with SQL queries, then probably go with Bigtable. It's the best option for you. It has a high throughput, less latency, so the faster transaction is very fast for you, and you can store the data inside Bigtable. Now we are done with the theory.